There are different ways to run Linux processes in the background, and the most straightforward one is using ampersand at the end of a command. So as an example, I'll start a terminal here. Now this parent here has started this child here, and as a consequence, I cannot return to the parent terminal to type in any commands. Now a way to get around this is to kill the child process. But if you want to keep that child process open, what you can do is run in the background. So if I type in st ampersand, what happens is it creates the child and then returns to the parent terminal so that I can still do stuff in here. A consequence to this is if I kill the parent, then the child will die as well. Now, a way to get around this is to use disown. Disown abandons the parent, meaning it'll stay alive when the parent is closed, and it'll stay alive after logout. So if I type in st ampersand disown, what happens is if I kill this parent here, the parent will die, but the child will remain alive because it is no longer tied to it. A more complicated thing you can do is use nohup. So nohup, instead of being put at the end, is put at the beginning. If you type in nohup surf, as an example, this is my browser, and then ampersand disown, I'll use all of them just for fun, then it'll start this surf child here. And if I type in pkill hup surf. Now, I'll explain what this command does. So pkill is a version of kill that instead of using UIDs, it uses the name. So it searches UIDs for the process name. The -hup, hyphen signifying that a signal should be sent, and hup is the name of the signal. Hup means hang up. Hang up signal is sent when you log out, and from other processes, it is a very light way of telling a program to close. So nohup means that surf will ignore hang up signals. So if I send this, it will not do anything. Another thing that hup does is it puts the output of the program into a file called nohup.out. I'll give you an example. I'll go into my scripts, and I created a script that just counts upward every second. Here it is. Now, as you can see, there's output every second from that process, and if I run it with nohup, what this will do is, instead of putting the output into my parent terminal, it'll put it into a file called nohup.out. See here, 8 seconds. Now if I cat that file, it's 13 seconds at this point. If I keep running that, you'll see that the output is still going into that file every second. Now what I can do is kill all count, and that'll kill the process. If you nohup to process and you logged out and logged back in, the process will still be running. So this can be useful if you are logging into something and you want to run a process that takes a while, but you don't want to have to remain logged in. So another thing you can do is redirect the output so that you don't receive any of it at all. So instead of saving it into a file, you don't receive any output. So the way you can do this is to start a program. In this case, I will start count. Now, as you can see, it's giving me output. Now, what I can do is put the output operator, and I can type in /dev/null. Now, as you can see, I'm getting no output. You can get more specific with this. So as you can see, what we did is redirect all output to null. Now, another thing you can do is only do minor problems or only do serious problems to null. So for an example, this is considered a minor problem when you have standard output. So if I type in 1 to count, it'll still redirect it. But if I type in 2 for major problems, then I will still get seconds because these are not classified as errors. To elaborate more on signals, signals are one of the most basic types of inter-process communication. You are probably already familiar with signals because you've Control-C. What this does is send an interrupt signal to a child process. Another thing you can do is send signals remotely to other processes. So if I start count again, and over here in this terminal, I type in pkill to find the UID of the process I specify, and the process is count. And then before that, I put in hyphen and then the name of the signal I'd like to send. For an example, I will say SIGTERM. What this does is send the termination signal to count. If I hit enter, count will terminate. Now, this is a way that processes can communicate with each other. This is an example of another way to stop a process. The final signal I'd like to talk about is SIGKILL. So if I repeat this command here and replace SIGTERM with SIGKILL, and I run count here, and I hit enter, it'll kill the process just like before, except what killed means is it forces the process to terminate. This means that no matter how process handles signals, it will always be terminated because this is the actual kernel killing this process. The process has no way of handling kill signals. I hope that you found this helpful and informative. Like, comment, and subscribe for more content.